Welcome to the Deep Dive. Today, we are taking a really granular look at the two defining platforms of modern software development. I mean, GitHub and GitLab. For you, the learner, whether you're, navigating a complex enterprise setup or prepping for a big meeting or maybe just studying for that next certification, understanding the differences here, the real architectural and philosophical differences, it's absolutely foundational.
That's really the mission for today. We're trying to move far beyond just a simple checklist of features.
Yeah.
Our goal is to clarify the, let's call them structural and ideological divergences across the entire development lifecycle. Because when you understand the why behind each platform's design, you start being just a user. You start to become a genuine expert in the DevOps ecosystem.
Okay, let's unpack this then. I think we have to start with the philosophy, because really, every design decision, every architectural choice, it all traces back to the core belief system of the product.
It absolutely does. And these platforms, they really represent two entirely different visions for how a development team should operate. On one side, you have GitLab, and they are all in on the single application approach.
The all-in-one suite. So tell us, how deep does that integration commitment actually run?
Oh, it runs deep. I mean, it's in the platform's DNA. GitLab's stated goal is to provide every single function a DevOps team could possibly need. We're talking source code management, continuous integration, security testing, monitoring, artifact registry, all of it, all in one cohesive UI. They literally want to replace what might be 10, maybe 12 different single-function tools with their one integrated system.
And the benefit there is supposed to be, what, seamless handoffs?
Yeah.
Minimal friction to get started.
Exactly. That sounds extremely appealing on paper, right? You reduce all that tool sprawl. But what's GitHub's counter-argument to that?
So what's their competing philosophical stance?
GitHub takes what we call the best-of-breed approach. They focus on providing absolutely outstanding core functionality, source code management, code review, and CI/CD through actions. But they are perfectly happy to let others handle all the specialized tasks. They lean very, very heavily on their robust marketplace.
Which has thousands of third-party integrations for everything.
For everything from vulnerability scanning to sophisticated deployment orchestration, you name it, there's probably an app for it.
Okay, so this philosophical tension is actually critical for anyone who's building a workflow. If I choose GitLab, I'm getting immediate guaranteed integration, but I'm also kind of tied to their roadmap and their specific tools.
You've just hit on the major trade-off. With GitLab, you get that unified user experience, that tight integration, which is great, but you are accepting a degree of, let's be honest, vendor lock-in. If you decide 6 months down the line that you prefer some other, niche security scanner or a different issue tracker, well, integrating it might require some serious workarounds. Or it just might not work as smoothly as the built-in system.
And on the flip side, choosing GitHub the best of breed gives me incredible flexibility to swap tools in and out.
Yeah.
But I'm paying for that with management complexity.
Precisely. You gain all this modularity, but you introduce what some people call integration fatigue or just tool sprawl. Your security team might use one vendor, your dev team another, and now your platform team is spending all their time managing APIs, tokens, and just monitoring the health of all those connections between the systems. So for you, the learner, you really have to weigh that ease of maintenance from GitLab against the specialized flexibility of GitHub.
That clarity on the foundational why is hugely helpful. Now let's shift from philosophy to language, because this industry loves its jargon, and sometimes things that are functionally identical have completely different names.
Oh, this is such an essential mental translation you have to make. If you're interviewing or moving between companies, you just have to know the swap. We're talking about the main way we do code collaboration and review,
Which GitHub famously calls a pull request.
right, a PR, and GitLab calls it a merge request.
An MCR, functionally, it's the exact same thing. It's a request for a reviewer to look at your code changes before they get merged into the main branch.
It's a simple distinction, but it's absolutely critical for translating your skills across environments. But the real nuts and bolts, the place where that philosophical split really shows up in the code, is how CI/CD is configured.
Continuous integration, continuous deployment.
Okay, so where do I actually define the automation pipeline that builds and tests and deploys my code?
The physical location and the structure of those files, they perfectly mirror the philosophy we just talked about. So if you're in a GitLab environment, you are dealing with a single, highly centralized file.
And that file is always call.
It is always named .gitlab-ceci.iml, and it lives right there in the root directory of your repository. This reflects that single application idea, one place, one entry point, All your control is centralized in that one pipeline definition. Okay, so if I have a massive project with stages for, say, building artifacts, running security scans, deploying to staging, and then deploying to production, all of that logic is inside that one single, potentially massive YAML file.
Precisely. That is the GitLab way. Now contrast that with GitHub. They use that modular best-of-breed approach even for their workflow definitions, usually through GitHub Actions. Their configuration lives in a dedicated, nested directory.github workflows.
And inside that directory, instead of one giant file, what do we usually find?
We typically see multiple specialized YAML files. For example, you might have a build.eml for compilation unit tests, and then securityscan.eml that triggers your third-party SAST tool, and then a separate deploy production.eml for the final release. This modular structure, it lets your engineering team separate concerns very clearly. You can assign different files and even permissions to different stages or teams.
That flexibility becomes incredibly powerful, right? Yeah. If you're integrating some specialized third-party tool into just one part of your flow, you only need to touch that one little YAML file, and you don't risk breaking the entire centralized pipeline.
It just allows for greater delegation and compartmentalization. It's sort of the difference between managing one massive ledger, like in GitLab, versus having several small dedicated notebooks, like in GitHub. Both work, but they impose very different organizational structures on your team.
That really makes the structural difference tangible. Okay, let's move from the config files and talk about architecture, specifically how these services are hosted and how they manage organization-wide complexity.
Architecturally, yeah, the divergence starts with the core business model. GitLab operates on what's called an open core model. This means a pretty significant portion of their platform, the Community Edition, is open source.
And what's the big practical implication of that open core model for the learner or for an enterprise?
It makes self-hosting incredibly accessible. Let's say you're a company operating under really strict regulatory requirements, finance, government, something like that, where data sovereignty means your code can never touch a public cloud. Well, GitLab offers a mature, easy path to running the entire platform on your own hardware, behind your own firewalls.
Which has to be a huge selling point for those large, heavily regulated organizations.
It's massive. Absolutely. Now, GitHub, while they do offer solutions like GitHub Enterprise Server, it functions primarily as a SaaS platform, software as a service. Their whole ecosystem, the marketplace, the underlying architecture, it's all optimized for a highly available multi-tenant cloud experience. So while they have on-prem solutions, their core gravitational pull is always towards the cloud.
Okay, so beyond just hosting, let's talk about scale. When a company is managing not 10, but maybe 500 projects for multiple business units, permission management just becomes a nightmare. How does GitLab address that with its architecture?
Right, and this is where GitLab has historically had a really unique advantage, one that's tailored specifically for large-scale enterprise management. And that's the concept of subgroups.
Subgroups. So that essentially creates a nested hierarchy for your repositories, right?
Mm-hmm.
It moves beyond the traditional flat organization structure. But why is that inheritance part so crucial?
Okay, imagine a massive enterprise. Let's call it global tech. Underneath that, you might have subgroups like finance, R&D, and shared services. Then, inside finance, you might have even more nested subgroups like payment processing and reporting.
So it's a tree structure, not just a long list.
Exactly. And what makes this so powerful is the cascaded permission inheritance. If I, as an administrator, grant a team read access to the shared services subgroup, every single project nested 3 or 4 levels deep under that group, from API libraries to logging tools, it automatically inherits that permission.
That sounds like a massive time saver. For large-scale onboarding, for auditing?
It is. It radically simplifies access control. In a flat structure, which GitHub traditionally favored, if you had 500 repos, you'd have to manually add those permissions to potentially hundreds of individual repos. Or you'd have to rely on external scripts and tools to enforce that logic. GitLab just baked the hierarchy right into its core. That's a key differentiator for managing really complex organizations.
That is a phenomenal piece of insight, connecting the architecture directly to day-to-day operational efficiency. Okay, so we've covered philosophy, terminology, configuration, and architecture. Let's tie this all back directly to your learning goals. If you are focusing on the GitLab ecosystem, maybe you're aiming for a certification, why is it mandatory to spend all this time learning about the competition, about GitHub?
Because the comparison is the ultimate clarification tool, you really need to understand the alternative to truly appreciate the design choices of your platform. By knowing GitHub's modularity, you gain a deep appreciation for the integrated GitLab flow and its whole end-to-end DevOps lifecycle.
It provides context. You're not just learning what GitLab does. You're learning what it's actively trying to solve compared to the industry standard.
Precisely. And for exam strategy, and just for practical application, you need to focus on those specific built-in features that really define GitLab's single application vision. When an exam asks you about the advantages of the integrated lifecycle, what they're looking for is specific evidence that you're avoiding external tools.
Okay, give us the prime examples, the ones that really cement that integrated advantage.
The main ones are around security and deployment artifacts. So first, the built-in SAST, or static application security testing, that's critical. In a traditional modular setup, you might run SAST as a separate step, handled by some external tool. With GitLab, it's integrated directly into the MR process.
So the security feedback happens right there in the same UI, without exporting reports or switching context between tools.
Correct. When a developer creates a merge request, the security scan often runs automatically before the code review even begins, and the findings pop up right in the merge request widget. This is what we mean by shifting security left. It makes it part of the native developer experience.
And the second example?
Integrated container registries. Okay, you build a Docker image. Where do you store it? In the GitHub best-of-breed model, you might use Docker Hub or a cloud registry like AWS ECR. GitLab, reflecting its single application approach, provides its own native container registry. It's part of the same platform, sharing the same permissions and UI as your source code.
So for the learner, knowing that GitLab has subgroups, built-in SAST, and a native container registry, those are the key points of uniqueness that define their commitment to being that single integrated toolchain.
They are what define the key advantages of that single application system, and understanding those integrated components is what distinguishes a user who just follows instructions from a professional who understands the system's architecture.
This has been incredibly clarifying. Let's do a quick recap of the most critical takeaways for you, the listener. First, remember that core philosophical tension. GitLab prioritizing the single application for tight integration and, minimal tool sprawl, versus GitHub favoring the best-of-breed approach, leveraging massive flexibility through its marketplace.
Second, do not get caught by the language trap. GitHub's pull request is GitLab's merge request. Functionally identical, but knowing that terminology swap is non-negotiable.
And finally, pay attention to how that philosophy dictates the architecture. The centralized .gitlab-ci.iml file versus the modular.github workflows directory. And of course, the power of GitLab's hierarchical subgroups for enterprise-level permission management.
And with this understanding, you are now equipped not just to navigate the features of these platforms, but to really understand the fundamental business decisions driving their development, and crucially, their placement in the evolving modern tech stack.
So a provocative final thought for you. Given GitLab's bold goal to replace 20 or more tools with one tightly integrated platform, what are the inherent trade-offs for you as a user? What's the trade-off in terms of potential vendor lock-in, making it harder to migrate services later, versus the sheer complexity and integration burden of building and maintaining a highly modular, best-of-breed system? That's something for you to mull over as you build out your next workflow. Thanks for diving deep with us. We'll catch you next time.